This is Dr. S. Muthukumar, Assistant Professor from K.S.Rangasamy College of Technology. In this video, I am going to explain about the correlation and spectral density of a random process. First of all, what is random process? Random process is the collection of random variable and the time parameter t. That is, if the signal is characterized by using the probability model, means then the process is random process. Okay, so the random process is mostly characterized by autocorrelation and spectral densities. What is autocorrelation? Autocorrelation is mainly used to find the changes in the signal with respect to the time. That means the value of autocorrelation reduces with respect to time, means the process of the signal is also reduced. Densities, that is power spectral density. So it is mostly used to find the distribution of the power of a signal. Now come to the definition for autocorrelation. So autocorrelation of a random process x of t is defined by the expectation of two different times. It is e of x of t and x of t plus tau. It is denoted by capital R of tau. Tau is the time difference. Then spectral density is defined by using the formula of integral over minus into plus infinity r of tau into e power minus I omega tau d tau. Then the relationship between these two terms, that means autocorrelation and spectral densities. So r of tau equal to 1 divided by 2 pi into integral over minus into plus infinity s of omega into e power I omega tau into t omega. That means Fourier transform of power spectral density gives the value of autocorrelation function. If its inverse means, that means Fourier's inverse transform of autocorrelation function gives the power spectral density. So both are Fourier transform pair. So these equations are known as Wiener-Knudsen relation. Now we are using these two relations to find the other terms. So this is the first problem. Find the autocorrelation function of the random process x of t equal to a into cos of omega t plus theta if a and omega are constants and theta is uniform in 0, 2 pi. Here a is the amplitude of the signal and omega is the frequency and theta is phase deviation. Here theta is uniformly distributed in the interval 0, 2 pi. That means interval over f of theta equal to 1 divided by 2 pi. Apply the uniform distribution. 1 divided by 2 pi in the interval 0 less than or equal to theta less than or equal to 2 pi. So now find out the autocorrelation function of the process x of t or x of t comma t plus tau. So assume the initial time as t and the next time is t plus tau. It is the expectation of x of t into x of t plus tau. So now apply the formula of expectation of a random variable. E of x of t is the interval over minus infinity to plus infinity x into f of x dx. Here the variable is theta. So interval over 0 to 2 pi. That is theta varies from 0 to 2 pi only. So minus infinity plus infinity becomes 0 to 2 pi. X of t, this one, a into cos of omega t plus theta. Then x of t plus tau. So replace t by t plus tau in the x of t equation. That means a into cos of omega t plus omega tau plus theta into function f of theta, that is uniform distribution function 1 divided by 2 pi d theta. Now integrate this function. So 1 divided by 2 pi is the constant one. Take the outside of the integral. Then a into a square also the constant one. Takes the outside of the integral. Then check the remaining value. So it is in the form of cos a cos b. That means cos of omega t plus theta equal to cos a. Cos of omega t plus omega tau plus theta equal to cos b. So now apply the expansion of cos a cos b, which is equal to 1 by 2 into cos of a plus b plus cos of a minus b. So I add these two terms. That means cos of 2 omega t plus 2 theta plus omega tau plus cos of subtract it. So omega t minus omega t becomes cancelled. Then theta minus theta is equal to 0. So the only term is minus omega tau, cos of minus omega tau. So now use the concept of even and odd function. Cos of minus theta equal to cos theta. So it becomes cos of omega tau. So now integrate this term with respect to theta. Here there is theta term. So integration of cos becomes sine. So sine of 2 omega t plus omega tau plus 2 theta whole divided by its coefficient 2. Here there is no theta term. So consider it as a constant. So constant into integral, constant into variable. That is cos omega t plus d theta integral becomes theta. Then apply the limit 0 to 2 pi. So while applying the upper limit, the first term equivalent to sine of 2 omega t plus omega tau plus 2 into 2 pi minus apply the lower limit here. Sine of 2 omega t plus omega tau plus 0. Then use the term here. Use the term here. That is means replace theta by 2 pi and 0. So for the first term, both the values are in positive and negative form. So it becomes 0. The second term is for the lower limit value 0, for the upper one 2 pi into cos omega tau. So cancel these 2 pi and 2 pi value. So the autocorrelation function becomes a square by 2 into cos of omega tau. So the next one, the autocorrelation function of the random variable is given by Rxx of tau equal to 1 minus modulus of tau divided by t. For modulus of tau less than or equal to t and 0 for modulus of tau greater than t. Find this power spectrum. So use the Fourier transform formula here. S of omega equal to integral over minus theta 2 plus theta r tau into e power minus I omega tau d tau. So r tau is the given one. So modulus of tau less than or equal to t means tau varies from minus t to plus t. So this is the limit. For the other limit minus infinity to minus t and t2 plus infinity are 0. So no need to consider the 0 function. And then expand this term e power minus I omega tau. That means e power I minus I theta cos theta plus minus I sin theta cos omega tau minus I sin omega tau d tau. Now use the concept of definite integral. So this is an even function of tau. So because of tau is given in the form of modulus. Again consider this one cos of omega tau. So cos function is an even one. So even into even, again even. If integral over minus t2 plus t into even function is equivalent to 2 times of integral over 0 to t into function d tau. So now come to the second one. This is even function. Sine is an odd function. So even into odd function. So integral over minus t2 plus t into odd function d tau is equivalent to 0. So the second integral becomes 0. So no need to consider it. Now apply the Bernoulli's expansion here. 1 minus mod tau divided by. So we are cancelling modulus here because of here the limit varies from positive to plus t only. That is in the positive code axis only. So no need to mention the modulus here. Now use the Bernoulli's expansion u dv form. Okay. So now consider this is as u 1 minus t modulus of tau divided by t u. This is dv cos of omega tau d tau. So here the expansion is u dv. So cos of omega tau d tau integral becomes with respect to tau, sine cos integral with respect to tau sine divided by tau coefficient omega. Then u v minus form u dash, its differentiation tau differentiation 1. So 1 by tau minus sine integral cos omega tau minus cos omega tau divided by omega square, and then apply the limit values here. Okay. Here this is tau, not 1, this is here. First replace tau by t, so this is becomes 1 minus t divided by t sine omega t divided by omega minus cos omega minus into minus, so 3 times of minus, so becomes minus cos of omega tau t omega square minus lower limit. Now replace tau by 0, here the tau, so 1 minus 0 by t sine omega 0 divided by tau minus cos omega 0 divided by tau omega square. Here the cos 0 value 1, so minus into minus plus, so 1 by t omega square. So here the first term is 0 because of 1 minus 1 form. Here sine 0 also 0, so the balanced term is minus cos omega tau divided by omega t divided by t omega square. So now take this denominator as a common one, so it comes in the form of 1 minus cos 2 theta equivalent to 2 into sine square theta by 2. So the final form is 4 t omega square sine square omega t divided by 2. So this is the required power spectrum of the process. This is the evaluation of cross power spectrum, cross correlation function from the cross power spectrum. So given function is cross power spectrum, we have to calculate the value of cross correlation function. So use the Wiener-Ginichn relation, that is r of tau equal to, that is cross correlation equal to 1 divided by 2 pi into over minus into plus into s of omega e power I omega tau d omega. So replace the value here, given function. Here we cannot expand this function as cos theta plus I sin theta form because of this is neither even nor odd function. Okay, so use the direct integration. So this is u, this is v, so apply the u dv expansion here, u v minus u dash v1, so this is u term, so its integration e power I omega tau divided by with respect to omega, so coefficient is I tau, then minus, so its differentiation with respect to omega jb divided by capital W into e power I, this integral e power I omega tau divided by I square tau square. So limit varies from minus infinity to plus infinity. After applying the limits, this function will come in the form of sin theta and cos theta expansion of e power, that is e power I theta plus e power minus I theta divided by 2 form, and the another one is e power I theta minus e power minus I theta divided by 2i form. So after using these two formulas, we can get the cross correlation for the given function. Okay, thank you.